And for this problem, get 3 plus 7r. Now with this one, we have to multiply by I over I to get rid of the fraction. Okay, find the quadratic function with the vertex 1, -4, and the point 2, -3. You can plug the point in for a standard quadratic, then plug the second point in for x and y, and we find that a is equal to 1, which gives us that quadratic equation. Find the max or min of the quadratic function by completing the square. Well, first we have to put the function so the x squared comes first. We can pull out a -1, and we can make it a perfect square if we add 9, which puts a +9 at this end because of the negative sign out here, the mistake that I made during class. And then now we can complete the square. Now, since that parabola is a negative, that means my parabola is upside down, which means that vertex is going to be a max at the point 39. Now for another completing the square problem. For this one, I'm going to pull out the -2. And then we can add a +1 here to complete the square. But that means I added a -2, so I have to add 2 on the end of my equation. And then I can factor out the perfect square here. Oops. Not on highlighter anymore. And once again, since this parabola is upside down, my vertex of 1, 3 is a maximum. Okay, determine the right hand and left hand behavior of this polynomial function. This one's a parabola, but it's an upside down parabola, which means it's down to the left and down to the right. This one's a cubic, so it's down to the left and up to the right. And this one is a 4th power, so it'd be similar to a parabola, which means it's up to the left and up to the right. Okay, to solve this problem using long division, when we set this up, you have to be careful to put your 0 in for x cubed and your 0 in for x. And once we finish off our division, we get x squared minus 2 because it has a remainder of 0. Okay, this time we're going to use synthetic division. So once again, when you set up your synthetic division, you have to remember to put the 0 in for our x squared. And finishing off our synthetic division, that leaves us with 2x squared minus 4x plus 14. And then you write your remainder as a fraction. Okay, now to find the polynomial with these integers as zeros, you need to set up all of the binomial factors, multiply the first set together, and then keep multiplying. Find your like terms, multiply again, and we end up with our polynomial function that has those zeros. Find all real zeros of this function. We have to find the zeros by using synthetic division. So if you try out a 1, you'll find you get a remainder of 0. Now I'm going to use this new polynomial. And 1 works again. And now we're down to our binomial. So we can get our zeros of x minus 1, 4x minus 3, which gives us zeros of 1, 1, and 3/4.